Thank you for this opportunity to present to the House Environmental Resources and Energy Committee. My name is George Myers, and I am the Superintendent of the Milton Regional Sewer Authority, and with me is our consulting engineer, Chuck Wunz, who works for Herbert, Rowland, and Grubic Incorporated. We would like to start our presentation with a question. True or false? Efforts to produce cleaner effluents from Pennsylvania's and the nation's publicly owned wastewater treatment plants, also known as POTWs, result in even larger volumes of biosolids, which is the name given to sewage sludge, and in consuming more and more energy to do it. In other words, the cleaner you make the wastewater, the more stuff you take out of the water, and the more sludge you produce, and the more energy you consume. The answer is false. The amount of biosolids produced is more a function of the treatment process utilized to provide the required degree of treatment. Similarly, the amount of energy consumed to treat wastewater is a function of the processes selected. We are here, in fact, to tell you about the project soon to be bid at Milton, Northumberland County, Pennsylvania, that will expand the plant, produce a cleaner effluent, produce renewable energy, produce renewable fuel, and with no biosolids needing disposal. We need your support to do this project. Currently, the Milton Wastewater Treatment Plant is like every other wastewater treatment plant in Pennsylvania, and we produce one heck of a lot of biosolids. Biosolids come from the primary treatment and secondary treatment steps at the Milton plant. I am standing here at the primary clarifier where primary sludge is generated. The secondary sludge and the majority of the biosolids produced at the Milton plant come from this step. This is the activated sludge process where we have 800 horsepower aerating the contents of these two tanks. These are our sludge digestion tanks. Upon completion of processing in these tanks, the biosolids could be hauled to permitted farmland as we once did, but are now processed through a dewatering step so they can be transported to the Lycoming County landfill. This is the centrifuge that we utilize to dewater our biosolids. The centrifuge consumes 175 horsepower. Here we see the dewatered biosolids being conveyed into two roll-off containers. When the containers are full, the sludge is hauled to the Lycoming County landfill for final disposal. Now I would like to turn the program over to Chuck Wunz, who will tell you about how we will be changing the plant so that it will be producing no biosolids needing disposal.
The Milton Wastewater Treatment Plant currently produces and ships 10,400 tons per year of biosolids to the Lycoming County landfill, making it the landfill's second largest customer. That is 20,800,000 pounds going to the landfill each year at a cost to Milton of $400,000. When our project is complete, the amount of biosolids going to the landfill will be zero. Our project will produce 2,190 tons of renewable fuel each year, having the same heat production capacity as the burning of wood chips, about 7,500 BTUs per pound, and with a value of $100,000. The net savings to Milton is $500,000 per year. This is a graphic artist's rendering of the proposed treatment plant. The background is an aerial photograph. The packet we have distributed shows the same slide. The anaerobic process is in the big new tanks on the right. The activated sludge process is in the center of the slide. The current electric bill at the plant is $400,000 per year. After the project is complete, the bill for electricity will be zero. America's environmental engineers are in love with activated sludge treatment, but the activated sludge process produces about 5 times more sludge than an equivalent anaerobic treatment activated sludge hybrid process. We all should be considering anaerobic treatment technologies at every opportunity because less biosolids will be produced and less energy will be consumed. In some cases, like Milton, biosolids requiring disposal will be zero, and energy consumption from outside sources will be zero. This is a description of the anaerobic treatment process. Different microorganisms work together to process complex organics into methane and carbon dioxide. More energy is generated than is required for mixing. Many of these organisms are the oldest living species known to man. Instead of growing cell mass and creating excess biosolids, the process generates primarily 2 gases, methane, which is about 75% of the total volume, and carbon dioxide, which is almost all of the rest. Legislators and regulators need to recognize that the ways we adopted in the 1970s to treat our wastewater need to change. Electricity is ever more expensive, and biosolids disposal problems are always with us. PennVest rankings for the rating of projects are largely unchanged from the time PennVest was formed. What about changing the rating process to give a project like Milton's a priority because it eliminates biosolids disposal and produces renewable energy? If you don't, PennVest will not fund this project. These are the reasons the Milton project is important to Milton's sewer customers. The reasons for you to support the Milton project and adopt it as a model are to demonstrate that treatment processes can produce zero biosolids that otherwise would need to be disposed of, and can also produce renewable energy and renewable fuels. This can be done. With design flows increasing by 32% and design organic loading increasing by 290%, the hybrid anaerobic activated sludge treatment process at Milton consumes 30% less energy than the current plant, and in the future all of that energy will be generated on site. In addition, about 50% of the energy generated at the plant will be sold to the PJM electric utility grid. There are over 1,000 sewage treatment plants in Pennsylvania. How much renewable energy and how much renewable fuel can they produce? How much can the greater use of anaerobic treatment processes reduce the volumes of biosolids generated?
In addition to being a poster child for energy efficiency, renewable energy production, renewable fuel production, and innovation in reducing biosolids production, the Milton project provides capacity to allow ConAgra to expand to add to its 950 high-paying union jobs by bringing new food production lines to Milton, and fosters a brand new job creation concept: high-strength wastewater industrial parks. What city or town wants a new industry that has high-strength discharge without forcing the industry to pre-treat its wastewater? Milton does. These are how the costs of the project break out. We provided them for your later review and study. Thank you for this opportunity to present to the committee. Thank you for your attention, and thank you for your support in recognizing the importance of the Milton project.